Hi all, welcome to my YouTube channel, Know About Embedded System. In this video, I'm going to show you how to program general purpose input-output using LPC1768 microcontroller. So this will be a hands-on session. Again, I'm going to use a Keil software here, and using Keil software, how we can program LPC1768 microcontroller, especially general purpose input-output. So without further delay, let us start a video. So before starting, please subscribe my channel to know more about embedded system and to gain the knowledge on embedded system. Let us start the video here. So general purpose input output. I don't want to explain more on general purpose input output because we have already explained and we have made many videos on this. So my scope for today's video is to do the programming for GPIO and the LPC1768 microcontroller. So you know that already. What is the general purpose full form? GPIO full form, general purpose input output. So this general purpose input output you can use for any general applications such as LCD, LED, motor interface, and the all display devices and so on. So many examples we can give for general purpose input output. So under this general purpose input output, LPC1768 microcontroller is having these many port pins. So you should remember always GPIO general purpose input output will come with the ports. So this GPIO what you're seeing, so this will come with the ports. General purpose input output will be having a different ports. Ports are nothing but connecting terminals. These are all the connecting terminals. So how many terminals available in this GPIO for this LPC1768 microcontrollers? So you can see on the screen totally about this LPC1768 microcontroller is having totally 5 GPIO ports, and they have given the names like this. They have given the name like this. So names are defined like this. So what are the different names they have given? They have given the names port 0, port 1, port 2, port 3, port 4 like this. So there are totally 5 ports available: port 0, port 1, port 2, port 3, port 4, and port 5. In port 0, 31 pins available, and port 1, 32 pins available, port 2, 14 pins available, and then port 3, 2, and port 2 also, port 4 is also having 2 pins. Altogether, the total GPIO pins available is 81. So there are totally 81 GPIO pins available, and out of this 81 GPIO pins, programmers are allowed to program only 70 GPIO port pins. Even though there are 81, there are some restrictions are there. Out of 81, we can program 70 port pins. Okay. Now, coming to the second point here. So GPIO, how to program GPIO? So GPIO, not only GPIO, any peripherals are allowed to program with the help of registers. Each peripheral will have different registers, and each register will have its own control bits and configuration bits. Okay, so like that. So currently what you're seeing, general purpose input output in this microcontroller is having mainly there are different registers are there, but mainly we have 4 important registers which we will be using in our coding part. The first one is called FIODIR. This is called FIODIR. Then we have FIODIR, set, clear, and pin. Okay, so FIODIR stands for FIO stands for fast input output. So what is the meaning of FIO? Stands for fast input output. Fast input output. This is the meaning. FIO stands for fast input or output. DIR stands for direction. We have FIODIR stands for fast input output direction. This register is used to configure the direction. This is used to configure the direction. So direction in the sense GPIO port pins can be configured as in both way. You can configure as an input port or you can configure as an output port. Okay, so if you configure these registers, FIODIR register with a 0 value, then the port will be configured as input port. And if you configure FIODIR register with 1, then that is going to configure as an output port. Very simple definition. FIODIR, direction configuration. 0 if you load, it will be input port. 1 you load, it will be output port. The second register, FIOSET, fast input output set, and this fast input output set is used to set the port pin to high. If you want to set any port pin to high, then we have to use this one. And if you want to clear any port pin, so we have to use FIOCLR. Okay, the last one is FIOPIN. FIOPIN is used to check the status of port pin. Okay, so in detailed video, I have already uploaded one more video working with the Keil software. You can watch that video in detail. I have explained there. Okay, so with this introduction about GPIO register directly, I will come back to user manual here. This is the user manual. You can see the chapter number 9. So I have already told you there is a user manual, and you can see here chapter number 9. So this chapter number 9 says about general purpose input output. Okay, so here they have explained what is general purpose input output, what are the different applications you can do, and so on. You can see here finally they are giving with applications also. You can go for any driving the LED, controlling the off-chip devices, sensing, and so on. Okay, and this is what I have explained you. We have port 0, 1, 2, 3, 4, and every port pin is having its own pin numbers. Okay, port 0 and so on. And these are all the different registers you can see here. GPIO register map. Each peripheral will have n number of registers, 20, 30 different registers. But here we have 1, 2, 3, 4, 5, 6, 7, 8. There are around 12 registers are there. But out of this, I am considering only 4 important registers. One is FIODIR, FIOPIN, FIOSET, and FIOCLR. Okay, so with this, let us do the first program on GPIO. Okay. Yeah, so in the previous video, I have created one file, and I have explained you how to create a project for Keil using, how to create a project for LPC1768 using Keil software. So I'm using same project here, and the same file I'm going to use, and I will do first coding like this. So I'll just keep it in full screen mode. My question, my program, I'll write here. I wanted to toggle port 0.0. Okay, I wanted to toggle port 0.0. Okay, so I have already shown you what are the different ports available. So there are totally 32 pins are defined for port 0. Out of that, I'm going to use only one port, that is P0.0. That means 0th pin of port 0. Okay, now let us write a code here. So what I will do, so this is a notation we have to follow in our LPC1768, and this is the name of the register, FIODIR. Is equal to 1 left shift of 0. Okay, so what is the 1 left shift of 0? I'm just configuring here. I'm just telling here config P0.0 as output port. Okay, so what is the meaning of this 1 left shift of 0? This is nothing but a masking. So we will call this part as a masking. Regarding masking, I have already uploaded a video. You can watch that video. Okay, so this is my first point. We have to do it, and then I'm going to create a while of 1 here, and then I'll just copy this statement and paste it here, and then I'll just remove small changes here. I want to set, and then I want to clear it. Okay, so what is the FIOSET? FIOSET stands for set P0.set set P0.0, and then I'm going to clear here. Clear P0.0. In between, I'll add some delay here. delay approximately 100. I'll give what is delay program we have to write. I'll just write it after this. Yeah, this is a simple program to toggle one port 0.0. This is my simple program, and very important. If you're facing any interviews, if you want to attend any interview, definitely in the interview also they will ask you, can you write a program to toggle one port pin like that. Okay, so now I will write delay code here. So delay, so unsigned int a. I'll create two variables here. I'm going to write a simple for loop here. Simple for loop this is, and then for j is equal to 0, j less than some 10,000, 5,000, and then j plus plus. So this code will generate approximately 1 second delay for 100 times, or for 100 value. Okay, so just this is a function to, it will just keep in mind this function will generate a small delay. That's it, no need to remember anything. So I'll write here void delay unsigned. Okay, so now this is a program. Now let us check whether will it work or not. I have already added my code into the source group, so that's why no need to add once again. If you're doing newly, definitely it has to be added to the source group. This is my source group, and here you need to add your test code. Okay, now I'll just compile. You can see here there is no any error, and then I'll just build it and rebuild it. There is no issue. The program, whatever we have written, it's fine, and it has to execute without any errors. So now let us go to debug window here, and then you know that already. So I need to open my port 0 here, go to peripherals, and then go to GPIO fast interface and take port 0 here. Okay, this is my port 0, and just allow to run here. This is a run option, and just you observe what is happening. Okay, okay, I made a mistake here actually. That's not the register mistake. So I forgotten here, it should be J. Now it will work. So there is a small correction required in the code. I forgotten to add a J here. So because of that, it was not debugging. So now let us check this. So now it has to toggle port 0. Yeah, you can see here. And then, yeah, 100% now it is working. Right? And you see rest all other bits of your port 0, it is in high impedance state. Nothing but all are 1111, but only the port 0.0 is toggling. So this is my this is my question, or this is my input. I need to toggle P0.0 using three different registers. One is FIODIR and one FIOSET and FIOCLR. So since I kept it in a while of one, this while of one indicates infinite loop. So please do remember here, this while of one is infinite loop execution. Okay. So let's check it, what happened. Once again. Yeah, now you can see continuously it is toggling. Okay, I hope this video is clear to all. This is my first program on LPC1768 microcontroller, And in the next video, I'll come up with one more programming exercise. And keep watching our YouTube channel, Know About Embedded System, and please subscribe my channel. Thank you. We'll meet again with one more video and one more programming exercise.